So in the previous sessions, we were recollecting the general wave equations, the transverse magnetic mode wave equations, and the transverse electric mode wave equations in a rectangular waveguide. And we already also saw that the transverse electromagnetic mode will not exist in a rectangular waveguide because all the field expressions are going to become zero. So these are the equations for the transverse electric mode in a rectangular waveguide, and we know Ez is 0. We derived this from the Helmholtz equation, and by substituting these two, Ez and Hz, in the general wave equation, we obtained the expressions for Ex, Ey, Hx and Hy. And I said that we need these wave equations for drawing the field patterns of the modes, right? So we are going to take the dominant mode of the transverse electric wave, and the dominant mode is going to be TE10. So the subscripts M is going to be 1 and N is going to be 0. So when I substitute M and N to be 1 and 0 in these equations, the equations will be reducing to something else. So when I am substituting M is equal to 1 here, so Ez is going to be 0. When I substitute M is equal to 1 cos pi by Ax, and when I substitute N is equal to 0, this whole term becomes 1. Okay, so I'll be having e power j omega t minus gamma z. So Hz became c cos pi by Ax e power j omega t minus gamma z. So when I substitute m is equal to 1 and n is equal to 0, what happens to Ex? This entire term becomes 0 because we have a constant term which has n. So this entire term is going to become 0. Now I don't have the electric field in x dimension. Now when I substitute m is equal to 1 and n is equal to 0 in this equation, so this term becomes 1 because cos 0 is 1. So this equation is going to reduce to this. Same way when I substitute here, m is 1 and n is 0, cos 0 becomes 1 once again. So the equation has reduced to this. And here once again m is 0 and m is 1 and n is 0. What happens? This whole term becomes 0. So for a TE mode, I have the components Hz, Ey and Hx existing, and I do not have these three components to be existing, Ez, Ex and Hy. So I have three components out of 6 field expressions, Ex, Ey, Ez, Hx, Hy, Hz. I do not have Ez component, I do not have Hy component, and I do not have Ex component. I have Hx, Ey and Hz component to be existing in the rectangular waveguide for a TE10 mode. So this is the dominant mode for transverse electric mode. Okay. So by reducing this equation some more, we will see what are the expression we are getting. So at initial time t, I'll drop this off. At initial time t, which means 0, I will not have any losses, which means alpha will be 0. When I am starting to send the electromagnetic wave at time instant t is equal to 0, the propagation constant, which is alpha plus j beta, will not have any losses ideally. So I will take this alpha to be 0. I will have only j beta. Okay, so this is happening at the initial time t is equal to 0. So I will consider gamma to be, in these equations, gamma to be just j beta. And I also know that e power minus j pi by 2 can be written as cos pi by 2 minus j sin pi by 2. What is cos pi by 2? 0. And minus j sin pi by 2 pi is 1. So I can simply write it as minus j. So e power minus j pi by 2 is minus j. Same way e power plus j pi by 2 can be written as plus j. Okay. So what is h square? While deriving the TM modes and TE mode equations, we saw a h square is going to be equal to the summation of the square of the constant terms a squared and b squared. I hope you remember. And we also found out these constant terms values to be n pi by b the whole square, and b was m pi by a the whole square. Right? So h square for t10, where m is equal to 1 and n is equal to 0, will be varying now. So when I put n is equal to 0, this term will become 0, and when I put m is equal to 1, this becomes pi by a square. So h square will become just pi by a square for TE10 mode. So we are considering the initial conditions where t is equal to 0 and propagation constant will be having only j beta term, where with no losses, alpha is 0, and we are just considering e power minus j pi by 2 to be minus j and e power plus j pi by 2 to be j. H square I am taking it as pi by a square. Just substitute all these terms in these equations. So I have t to be 0, this entire term will go, okay, e power j omega t, right? So this exponential term will go, and instead of gamma I have to put j beta. So e power minus j beta z. Here instead of minus j, can I put e power minus j pi by 2? Instead of minus j, just substitute e power minus j pi by 2. And instead of h square, can I put pi by a the whole square? So when I put pi by a the whole square, so this pi by a and one pi by a term is going to get cancelled. So this term will go. I will have this term as this, pi by a. And here e power j omega t is going to become 1, e power 0 it becomes e power 0 and it becomes 1, and instead of gamma you put e power j beta z. Okay. So this is going to become j beta, gamma is becoming j beta. Once again this is going to become the term 1, and here this is going to become minus j beta. We have reduced it. Okay. So after reducing this, still we can combine the exponential term and change this to, so this e power minus j pi by 2, if I am bringing it here, it becomes e power minus j beta z plus pi by 2. Okay, and instead of j, put e power j pi by 2. So I'll be having e power minus j beta z minus pi by 2. Fine. So I know this term is going to have a real term and an imaginary term. Real term in terms of cos and imaginary term in terms of sine. So if I'm considering that, so I'll remove all these things. So these are the assumptions we have to reduce the equations. The initial condition is the assumption. So e power minus j beta z plus pi by 2. I can write it as cos beta z plus pi by 2 minus j sine of beta z plus pi by 2. Right? So now cos beta z plus pi by 2 becomes minus sine of beta z minus j sine of beta z plus pi by 2 becomes cos of beta z. So I have a real term and imaginary term for this exponential value. Same way for this, I'm going to have e power minus j beta z minus pi by 2 can be written as cos of beta z minus pi by 2 minus j sine of beta z minus pi by 2. So I'll be having sine of beta z minus j cos of beta z. So for both the terms I have sine value in the real term, right? So if I'm substituting here, I'm taking all the real values. So Ez has become 0. I'm not considering that equation. Ex has become 0 and Ey has become 0. Okay. So now I have Hz, Ey and Hx. So take the real term . And consider all the constant to be a single constant. So here the real term is going to be cos beta z, right? So the entire term is cos beta z plus j sine beta z. I am taking only the real term. So real term of Hz, here it will become cos beta z. So here this entire constant term, you take it as a single constant capital C for simplification, okay? Because I need what is varying, okay? So this real term is going to be, so minus sine, so the minus all comes under the constant. So just take sine beta z, the real term, okay? Same way, the entire constant terms, you take it to be a single constant C. So you can put it as C1 and C2 for your identification. And this exponential is having the real term to be sine beta z. Okay. So what is the conclusion is, in the rectangular waveguide, x dimension is there, y dimension is there, and z dimension is there, right? So along, so if I'm considering Hz, it means that magnetic field is present along z dimension, this direction, okay? And also magnetic field is present along x direction also. So along x and along z I have magnetic field. So the magnetic field is going to be along x and z, x and z, x and z, x and z. So the magnetic field is revolving like this, okay? And electric field is along y dimension, which means the electric field is going to be only in y dimension. So the electric fields are going to be straight in this direction, and the magnetic field are going to be around it, okay? So we'll see the pattern of this TE10 mode. So we are saying only for TE10 mode now. So the pattern is going to be the electric field is along y dimension and the magnetic field is going to be along x and z dimensions, okay? And one more similarity if you see here, whenever EY is maximum, because both are sine and both are having the same values, right? Whenever EY is maximum, whenever the electric field along y dimension is maximum, then magnetic field along x dimension will also be maximum. So whenever I have the electric field along y dimension to be at the peak, the magnetic field along x direction is also going to be maximum in this direction and in this direction, okay? We'll see that field pattern now. So I think you have understood so far. Out of 6 fields, we do not have Ez, we do not have Hy, and we do not have Ex. We have one component of electric field and 2 components of magnetic field to be existing for a TE10 mode, okay? Now we will see the field patterns.